All right, AP, this is sample exercise 3.71. We're balancing a chemical equation again. At 1,000 degrees Celsius, ammonia gas, which is NH3, reacts with oxygen gas to form gaseous nitric oxide, which is NO, and water vapor. This reaction is the first step in the commercial production of nitric acid by the Ostwald process. Balance the equation for this reaction. Go ahead and press pause now, because here comes the solution. Alright, so the unbalanced equation, just by going by the names and understanding the formulas of the individual species, we have our ammonia plus O2 reacts to form the nitric acid and water gas. Because all the molecules in this equation are of about equal complexity, we can start by balancing it rather arbitrarily, meaning just pick something. Just pick anything. Here we're going to pick hydrogen, just because we got to pick something. A coefficient for NH3 and a coefficient of 3 for H2O gives us 6 atoms of hydrogens on both sides. Alright, so we've balanced the hydrogens. The nitrogen can be balanced with a coefficient of 2 on the NO. And finally, know that there are 2 atoms of oxygen on the left and 5 on the right. And so the oxygen can be balanced with a coefficient of 5 halves. Alright, so we end up with this balanced equation. However, the usual custom and what you'll need to do for this course and for the AP exam is to have whole number coefficients. Now, that doesn't mean that generating this is a complete waste of time. This can save you a lot of headache by just being simple and to the point. This is 5 halves. You now have a balanced chemical equation. Once you've done this, all you have to do to get to a complete, appropriate, balanced chemical equation, you simply multiply the entire equation by 2. And so this 2 becomes a 4. This obviously becomes a 5 because those 2 cancel out. 2 becomes a 4, 3 becomes a 6, and you're done. Because there are 4 nitrogens, 12 hydrogens, and 10 oxygens on both sides, this means that our equation is balanced.